In this video, we will look at how patterns can be created that wrap around to for a closed shape. Here is an example of a very simple pattern that wraps. It is a set of 6 lines that connect 6 positions. The positions are stored in a flat list. For the first 5 lines, the process is straightforward. Each line connects from index I to index I plus 1. For the last line, there is an issue. The last line goes from the last index to the first index, from index 5 to index 0. So the rule that each line connects from index I to index I plus 1 is not valid in this case. The code here shows how the lines can be created using a loop. But when the loop reaches the last line, there is an error. The issue is that the loop is trying to create a line from index 5 to index 6. There is no position at index 6, it will result in an error. One simple solution to this is to use the modulus operator. The modulus operator uses the percent symbol. The operator divides the first number by the second number and returns the remainder. In the example, we see that 2 positions are extracted from the list. For P0, the result of 5 modulus 6 is 5. So P0 will be set to position F. For P1, the result of 6 modulus 6 is 0. So P1 will be set to position A. Here you can see the code with the error fixed. The ode creates 6 lines. The last line wraps from the last position in the list to the first position in the list. Note that you could have achieved the same outcome using a conditional statement to check if the loop has reached the end of the list. However, the modulus operator is more concise. Next, let's look at some more complex examples. In this case, the task is to create a cube consisting of quad polygons. Note that there is a much simpler way of creating this tube. You can create a polyline and then extrude it upwards. However, we are using this case as an example to demonstrate an approach that can be applied to more complex cases. Here we see the positions that are used for creating the tube. There are 5 rings of positions stacked on top of each other. Each ring has 10 positions. Creating patterns that wrap tends to be easier with nested lists. So in this case, we use a nested list, consisting of a list of rings. The code shows the nested list structure. To extract a position out of the list, 2 indices are required. Note that for wrapping, it is the J index that is important. The last quad in the ring will need to wrap from J equals 9 to J equals 0. In order to create the quads, it is convenient to create a function. The code shows the quad function. The arguments to the function is the nested list of positions, the indices, and the width if the grid. The key thing to note is the use of the modulus operator. Whenever we add a number to the J index, we need to apply the modulus operator. This is what will make the quads wrap. At the end of the function, the quad polygon is created and returned. Finally, this code creates the tube of quads. It consists of 2 nested loops. Inside the inner loop the quad function is called. Next, let's look at some more complex examples. In this example, we will create a tube of hexagons that wrap. The hexagons are orientated vertically. The diagram shows how the hexagons on the right side of the grid are missing some positions. The diagram shows a smaller version. In this version, the tube would be 3 hexagons width and 2 hexagons deep. But the principle is the same. The hexagons on the right need to wrap to the left. For the diagram we can see that there are 2 columns of missing positions. The hexagons on the right side need to wrap around to the positions on the left. The red arrows shows how they should wrap for just 2 positions. As with the quads, we are wrapping focuses on the J index. The first step is to write the function for the vertical hexagon. The arguments to the function is the same as the quad function. The body of the function gets 6 positions out of the nested list. It then creates and returns a polygon. As with the quad function, the key thing to note is the use of the modulus operator. Whenever a number is added to the J index, the modulus operator is applied. This will ensure that the hexagons will wrap correctly. Finally, here we can see the code that creates the tube. The code has 2 parts, for creating pattern A and pattern B. Each part consists of a part of nested loops. Inside the inner loop, the function to create the hexagon is called. The key part of the code is the range functions. Another option is to create a tube with the hexagons oriented horizontally. The process for creating the sube is the same. We will briefly show the code. Here is the horizontal hexagon function. And here is the code for generating the tube. Here is a final example that shows that the pattern of positions can be any shape. In this example, the tube is following an arc. The pattern is created using the same process as before. We generate the A pattern and B pattern, and they interlock to create the final pattern.